In this video, what we'll be talking about is the measures of center of data. And in this particular one, we're going to be talking about the mean. What we're talking about when we talk about measures of center, they're commonly used numerical summaries of data to describe the center. This includes mean, median, and mode. What we're talking about is we look at the data and we want to know what is the center of it. And so we have to do it numerically somehow, and we look at three different types of measures of center, one being the mean, one being the median, one being the mode. What we're going to talk about right now is actually the mean. And so when we talk about the mean, it is a measure of the center of the data. It's usually what we refer to as the average. We all know how to do the average. We add up all the numbers and then divide by how many there are. And so when we're talking about mean in particular, many people think of it as the arithmetic average, but the formal definition of it is called the mean. So let's look at an example of this. In this example, we're going to be talking about hospital infections. This data show the number of patients in a sample of 6 hospitals who acquired an infection while hospitalized. We want to find the mean. So we have in one hospital there were 110 infections, in another hospital there were 76 infections, another there were 29 infections, 38 infections, 105 infections, and 31 infections. So as you can see, not all the hospitals have the same number, and so what we want to do is we want to find what's their mean, what's their average. And so to do that, we're going to take x bar, which is going to equal the sum of our x's, which is our data points, divided by the total number that we have. And we'll talk about these symbols here in a few moments. So x bar, which represents our sample mean, is going to equal 110 plus 76 plus 29 plus 38 plus 105 plus 31. And we want to divide that, and if we look here, we have 1, 2, 3, 4, 5, 6 different hospitals. So we're going to divide that by 6. And so when I do my calculation, I get 389 divided by 6. And so our mean is approximately 64.8. Anytime that we're discussing these things, we want to write them in a complete sentence. The mean of the number of hospital infections for the 6 hospitals is 64.8, which means on average each hospital had about 64.8 infections. Now obviously not all of them had 64, some of them had only 31 or 29, but this is an average because notice we have the 110 sitting up here. Now if you do this in your calculator, you're not going to get exactly 64.8. When you do it, you're actually going to get 64.833333. So what we do when we're talking about the mean, we want to talk about the rounding rules. And so the rounding rule for the mean is we round the mean to one more decimal place than the data. What this is referring to is if we have whole numbers, like we did on the last one, for the data, then we round our mean. The mean will have 1 decimal place. If we have the data with 1 decimal place, then the mean will have 2 decimals, and so forth. So in other words, whatever our data is, we want to take the mean to 1 more decimal place than that. And we have to follow our normal rounding, which means if it ends, let's say that we had 64.83333, and we're wanting to round to 1 decimal place, what we do is we look at the number to the left of it, and we ask, is that less than 5 or 5 or greater? If it is less than 5, we leave this number alone. And so our rounding for this case is 64.8. But in another example, we may have that it was 64.863333, okay? And we're still wanting to round to 1 decimal place in this particular case, not all cases, but in this particular case. So we look at the number directly to the right, so in other words the second decimal, and notice that it is larger than 5 or larger. So we actually round this number up, and we get that that is 64.9. So again, remember to follow your normal rounding rules when we're talking about this. Now I told you that we would get to some of the notation that I was just using, and so let's look at just x is whatever our data value is. So x is each individual data value. So most of the time our data sets are x1, x sub 2, x sub 3, x sub 4, and so forth. Notice that the numbers are subscripts, just refers to what position they're in. That's all it is, and the x's mean that they are data values. Now, we have two different n's. We have a capital N and a lowercase n. The capital N is the population size. You've already learned about population versus sample, and capital N refers to population size. Just means the number of values in a population. So how many data points were there? Lowercase n is the sample size. How many out of that population did we actually look at? And so that's what the lowercase n means. Now you also saw me write this symbol, which this is a capital Greek letter for sigma. So this is our sigma. And what it means is to add everything up. So we're just going to add everything up. So whenever I write it with the x, that means to add all the data points, or all the data values. Okay? You also saw me use an x bar. We do call this, or it is pronounced x bar. And what this represents is the sample mean. So it's the mean for just a sample. The other one is if we have a population mean, we have the actual entire population, and that is going to be the Greek letter mu. So That is pronounced mu. Let me put quotations around this up here. And that means the population mean. And you will need to know what these symbols mean and what they represent and everything. So what I've done in the notes is I've provided a notation sheet that we will just keep adding to throughout the course. One thing to note is when we're talking about mean, many people think that it is the typical value of all the data. That's not necessarily true, because it could be that it is much larger, much less, anything of that nature. But when we're calculating these, we have the sample mean, which is the mean of just a sample. And so that's going to be x bar, which is the sum of the x's divided by how many there are. Notice I used a lowercase n because that's the sample size. We, on the other hand, also use the population mean. That is referred to as mu equals the sum of our x's divided by a capital N, or the population size. Most of the time we will be calculating sample means because most of the time we do not have an entire population. Notice there is really no difference in the calculation of these. It is just the nomenclature and the symbols that are used to identify what it is. And these are extremely important when we're discussing this. So make sure that you know your symbols and what they actually mean. If you have questions on the mean, I will be glad to answer them.